Ladies and gentlemen, good evening and welcome to another session of Nambani Academy. We are currently busy with quantitative aspects of chemical change, and a homework activity was given for us to work on it and perform few calculations, in a sense that we just wanted to check and know where we are in terms of our calculations. Ladies and gentlemen, we must try by all means to follow the steps. The reason for following steps is it creates a sequence or a standard approach towards more complex problems. If we omit certain steps, we are going to experience a lot of challenges. Bonolo Matosa, how are you?
Fine, thanks. How are you, sir?
I'm doing well, thank you very much. Ba Anetse?
I'm fine, sir. Thank you for asking.
Thank you very much. Your Excellency, Mr. Nyoko.
I'm good, and you, sir?
I'm very good, thank you very much. Ratanang Phehlo?
I'm doing good, sir. Thank you.
Thank you very much. Landle Vezi?
I'm good, and yourself, sir?
I'm very good. Lesedi Katadi?
I'm good, and you, sir?
Very good. And the last one should be Baanetsa Mogesi.
Oh, so you already asked me, sir.
Okay, then it means it is Moteo. How are you, Moteo?
I'm good, and you, sir?
I am very good. Ladies and gentlemen, without wasting any time, let's get straight into it. The question was, what mass of potassium chlorate? Potassium chlorate must be heated to release 90 decimeter cubed of oxygen at STP. Now, the very first step, ladies and gentlemen, we agreed that we need to check what information is given. The very first information is the question wants us to calculate the mass of potassium chlorate. But the information given here is for oxygen at STP. So what does this say to me? This says basically to me, if I am given the volume of oxygen at STP, I can basically now calculate the number of moles of oxygen using V over VA. When I do this, then it means that I have 90 divided by 22,4, and this will give me now the number of moles of oxygen. So 90 divided by 22,4 will give us now something like 4,02 mole. The emphasis is on what? The emphasis is on me working with the number of moles of oxygen. Try by all means to inform the examiner or the marker to say, what is it that you are calculating for? Hence, I am putting the number of moles of oxygen in brackets, the O. But what does this say to me? It says now, I need the following step of mole ratio, because mole ratio is going to assist me in terms of now what? Of crossing the bridge of moving from the oxygen to the potassium chlorate. So what do I need in order for me to use now the molar ratio? I need to have the balanced chemical equation, which we wrote yesterday as 2 KClO3, giving us now KCl plus now O2. And we added a 2 here, and we had now a 3 there. So from this balanced chemical equation, one will be able to perform and do what? Molar ratio relationship. Between what? Between oxygen and potassium chlorate. So it means now when I want to do that, I will say the number of moles of O2 over the number of moles of KClO3 is just equals to 3 over 2. Where do I get this 3 over 2? From the balanced chemical equation. Then it will be easy to say 3 N of KClO3 is equals to 2 times the number of moles of O2, which will be just 2 multiplied by 4,02. Then we take a calculator, multiply by 2, then this gives us something like 8,0357, and we still have 3n of KClO3 divided by 3 divided by 3, and then the number of moles of KClO3 is equals to divide by 3. This gives us something like 2,67 more. Then I have the number of moles of potassium chloride. But when I have the number of moles, ladies and gentlemen, it's easy to say now N of KClO3 is equals to M over the molar mass, which will just be the mass 2,67, and I want now the molar mass of potassium chlorate. So the molar mass of potassium chlorate is K, which is 39, plus Cl, which is 35.5, plus now oxygen multiplied by 3, which is 16 multiplied by 3, and I am not sure. Let me just quickly check. I think this is 122,5. So it is 3 multiplied by 16 plus now 35.5 plus now 39. This will give us M over 122,5, 2,6, then multiply by 2,67. We find that the mass of KClO3 is equals to 327,075 grams. Then that is your final answer. Ladies and gentlemen, it will always be in a form of stoichiometric calculation. The stoichiometric calculation that wants us to follow steps and the sequence relating to the question. But Aneti, inputs, please.
Oh, so I see where I went wrong.
What was the problem of not basically going right the first time?
So I did not follow my steps properly, firstly. And I think I did this too quickly because I was not focusing. I mixed the 3 and the 2. And I used the formula that I was not supposed to use.
Thank you very much. Let me start with Lwandle.
So I wanted to know why didn't we, because I got the ratio and whatnot, but instead of multiplying by 2, I multiplied by 3 and then divided by 2. So I'm not sure if it's because of the way like the question, I don't know, but that's what I did. And I want to know like when I would have to do it the other way around. Like the question, I don't know if it gets me, like the question that it would, how the question would be phrased when we multiply and divide by 2.
Okay. What I usually do for me to note it, Bonolo, what I usually do is very easy. I usually put, maybe I must use purple. I usually put the one which is given on top. And the one that is given now is oxygen. And the molar ratio or the coefficient of oxygen is 3. Hence, it relates now to the given. That is the first thing that I do to eliminate now a confusion of where the 2 goes in and where the 3 goes in. So I choose the given to be the one on top, as the examples we did yesterday. And then at the bottom here, I put now the one that I say it is an unknown, or the question, or the one that I'm going to actually be looking for the number of moles. And then this also will relate now to the coefficient of what? Of the unknown also. That is how I do it. Such that I know that the one of given, which is at the top, goes hand in hand with the coefficient given. The unknown now also goes hand in hand with the one of the unknown also. So when it comes to multiplication, ladies and gentlemen, it will be easy. It's just cross multiply, hence the 3 there, cross multiply, hence the 2 there, next now to the oxygen. Follow up question, Lwandle. Maybe now you understand better.
Yes, sir.
Thank you very much. So in the near future, it basically means you will not now confuse them. Try to check which one is given. I usually put the one given on top and the unknown at the bottom. Ratanang Phehlo.
Sir, I understood everything that you have done. My only problem was that I didn't read the question properly, so that's why I got it wrong.
Okay. Your Excellency, thank you, Ratanang.
Sir, it's like I didn't know that we had to balance the equation because like they didn't give us like the
An
question
equation.
didn't say that something decomposed into oxygen and potassium chloride, so I didn't know we had to balance it.
Thank you very much. So now it basically says either the equation will be given or it will not be given. Remember in grade 10, as part of this particular topic, you are expected to write names of formulas and also formulas for the given name. So the expectation was once we see oxygen and potassium chlorate in one sentence, and the previous slide also explained that we are working with potassium chlorate producing KCl as well as oxygen. So that should have been a hint towards us. But I want to say, let's not worry. In most cases, equations will be given. But if the equation is not given, it is not a problem at all. What does it mean? It means now we will have to go back to grade 10 and also be able to write the correct formula from the given name, or even now the name form the given formula. Ladies and gentlemen, this was now homework activity that was given. So today I want us now to look into all this is done. I want us, yes, Lwandle?
Sorry, sir. I just wanted to know if when the equation is given and like say that we do it wrong, like we write it wrong, will the question, like the next question, be in positive marking, or will it just like the like marker stop marking?
Like negative marking. It's either positive or negative. Let me just say, we will give you the equation to avoid an issue of you not getting it right and now everything collapses and becomes completely incorrect. Because remember, we only testing certain skills. We don't want you to necessarily get 0 in all the questions, but the thinking should be, we will provide you with a question, a chemical equation. If it's not provided, then maybe we'll think of applying positive marking in that regard. So let's not worry about it for now. Let's emphasize the issue of getting the concepts correct. The questions will depend on what we have. And when we move to solidify everything we are doing, obviously we are going to bring about previous question papers as form of the exercises. So with that being said, let's move, ladies and gentlemen. Don't worry, this you already have the mole concept, calculating the moles, as well as molar gas volume. You have concentration, and I want us now to come here. More complex stoichiometric calculations. The very first line, ladies and gentlemen, says determine the empirical formula and the molecular formula of compounds. Determine the percentage yield of a chemical reaction, determine the percentage purity, and perform stoichiometric calculations based on equations that may include limiting reagents. Kindly switch off your mic, Lwandle. Thank you very much. So, ladies and gentlemen, we are going to start with let me do this. We are going to start with the percentage purity. Let me just get the correct pen. Percentage purity. Now, with percentage purity, what does it mean for us? It basically means we are interested in knowing the contribution of each element in the formation of a compound. So what it does is it informs us on what percentage does now each element consist in a compound. So you will be given a compound, and from the compound, we will be able to use that to determine the percentage purity, or let's just call it now for now, percentage composition, such that we do not confuse the purity and the composition. So what must happen before we get into this? We need to understand how one can use the periodic table. Composition and consists in a compound. So that is what it does. But the very first thing is we will be given a molecular formula. That must be given. Molecular formula should be given. Immediately from the molecular formula, ladies and gentlemen, we must do now this to determine the mass of the molecular mass. Okay, molecular mass of each element. Let me emphasize. Molecular mass of each element. And we quickly move to calculating the molecular mass of the compound. Calculate the molecular mass of the compound. So what does this mean? This is now the total molecular mass, 100%. Immediately thereof, we move and use the equation percent of an element is equals to, let me move it a little bit. Let's move it here. Of an element is equals to the number of atoms multiplied by the molecular mass of the element divided by total molecular mass of the compound. Compound multiply by 100. So unfortunately, this equation is not given in the formula sheet. So how can one try to remember this in a simple term? I am going to assign different letters to this. I am going to assign X for the molecular mass of an element and also assign Y to the total molecular mass. So now it will say percentage is equals to X over Y multiply by 100. But there is a problem now. What is the problem? The problem is we did not cater for the number of atoms. So I'm going to say let's add A, and A will represent now the number of atoms. So when it comes to percentage composition, we will need a molecular formula to perform that. But the first thing is to determine the molecular mass of each element. Where do we get the molecular mass of each element? We get the molecular mass of each element from the periodic table. So it means the periodic table will give us now this molecular mass of each element. Immediately thereafter, then we calculate the total molecular mass, and we are going to put it in this fashion of saying percentage of the element. So it will depend on which element I am referring to. Why? Because remember we said a compound, ladies and gentlemen, is a substance with two or more substance with two or more elements. That is now the reason why we will focus only on the elements in the compound. So ladies and gentlemen, let me give you now your 30 seconds to digest now that the concept of percentage composition has been addressed. We are going to do 2-3 examples relating to this, and we can move now to the empirical formulation. Moteo?
So is molecular mass and molar mass the same thing, or are they two different things?
It's the same thing, Lady Moteo.
Okay, thank you, sir.
Thank you very much. Luandle?
So I'm not quite sure where we're gonna get the number of atoms, because in my mind it's that calculation that we used. I think it's N over Na. I'm not sure if I'm correct, but yeah.
Okay. The number of atoms, let me emphasize it here. In this instance, we get it now from the molecular formula. So this will come now from the molecular formula. That is the reason why when I started, I said somehow the molecular formula must be given to us. Once the molecular formula is given, then it will be easy to identify the number of atoms. Let's just pause it there. And the example will put emphasis onto how we can use this particular problem. Moteo, your hand is still up.
Oh, sorry, sir. Let me put it down.
Thank you very much. Now, ladies and gentlemen, let's see if we can apply now this to some form of a calculation. Ladies and gentlemen, it says here, determine the percentage of iron in iron oxide. What is this? This is the molecular formula given now for us. So the very first step says the molecular formula must be given. The second step says identify the molecular mass of each element. So what do we have? M of iron. We also have M of oxygen. That is now us using the periodic table to identify the molecular mass of each element. Let me just quickly write it here. So from your periodic table, hence I said you will need now to have a periodic table with you at all times, because the periodic table brings about necessary information that we need to perform these calculations. So ladies and gentlemen, this will be something like 56 grams per mole. This will be now 16 grams per mole from the periodic table. Now, what must one do? Calculate. Yes, Lesedi?
So I was asking, aren't we supposed to calculate the molar mass for each element, but like the amount of atoms, like iron, there's 2.
Okay, Lesedi. Understood. Let's go to the notes and quickly check. Determine the molecular mass of each element. The part of how many atoms we have will come now when you calculate the percentage of an element. That is where the number of atoms will come in. But for now, we want the molecular mass of an element, not a diatomic element, not a compound, but now the element. I will show you immediately after we do the second step, which says calculate the molecular mass of the compound or the total molecular mass. So let's do that quickly. It will be now M of iron 2O3 Lesedi. That's when we can now consider that this is 56 multiplied by 2 And now this is 3 multiplied by 16. This will give us something like 160 grams per mole. That is where now your argument of multiply by 2 and 3 comes in. For us to get now what? The M total of the molecular formula that is provided. Immediately thereafter, we go into the percentage purity formula. Not percentage purity, sorry, it's percentage composition. But now the element in this instance is percentage of iron. What does it say? It says now the number of atoms. Let me write it down for us to remember. Number of atoms multiplied by molecular mass of element divided now by molecular mass of compound multiply by 100. Then it becomes easy. It's just now a matter of substitution. Multiply, sorry, by 100. How many ion atoms do we have? 2 from the molecular formula. What is the mass of the element? 56. What is the molecular mass of the compound? 160 multiplied by 100, and this will give us something like 70%. So what does this say? Remember, we said we are busy with quantitative aspects of chemical change, which is now the measure, which is now we are interested in the quantity. Thereof, it basically says 70% of iron or iron oxide is composed in this instance with what? 70% of iron. So this is how you go about calculating the percentage composition of an element in the molecular formula. Ladies and gentlemen, let me give you your 30 seconds for you to digest. Also ask questions, have your periodic table ready because you are going to perform few calculations for me and we will discuss that. Let me maybe start it and say, Ratanang.
Sir, if there were 3 molecules or atoms for iron, would you multiply by 3?
Yes, hence this number here says number of atoms. And where do we get it? We did say from the molecular formula. So the molecular formula will be a guidance of, am I going to multiply by 2 or am I going to multiply by 3? Because this number of atoms is influenced by the given molecular formula. Happy lady.
Yes, sir.
Thank you very much. Now, your 30 seconds starts now. Thank you very much. Ladies and gentlemen, I have an exercise here. It says determine the percentage composition of the following, but I just want you to do it for the highlighted elements. So for the first one, we are going to do it for copper. And for the second one, we are going to do it now for oxygen. So I will give you some time for you to perform these two calculations, and we will quickly discuss. I will give you now 3 minutes of each. So that will be 6 minutes, but I will give you something like 7 for you not to do it in a rush. Can even make it, and let's make it 7. And kindly send your answers to me. Thank you very much. Ladies and gentlemen, thank you very much. Your time is over. 1, 2, 3, 4, 5, 6. I just need one more answer, please. Kindly send, and then we will be in a position of discussing this one. Thank you very much. Received. Thank you. Received. Thank you very much. Ladies and gentlemen, let's just go straight into it without now wasting any time. We said the very first thing is to identify the molar mass of each compound. That will be now 63.5 grams per mole for copper. And then there's M also for sulfur. This is now 32.1 grams per mole. And we have oxygen, which is now just 16 grams per mole. And we want now the total, which is M of copper sulfate. Then this is 635 plus 32.1 plus 4 multiplied by 16. This gives you something like 159.6 grams per mole. Then the percentage purity of copper. How many copper atoms do we have? Just one. What is the molar mass of copper? It's 63.5 divided now by 159.6 multiplied by 100. Then the percentage of copper is 39.81%. Questions, please.
Oh, so when Ratanang asked you, I thought you said we should look at how many elements are in like the compound and not necessarily the coefficient. So I got confused there.
But now, when Ratanang asked, the question was, aren't we supposed to add the 2 or the 3 when we are working with these compounds here or elements? Then the agreement was we will only use that in the calculation of the total molecular formula as well as the number of atoms that we get now from the molecular formula. Only that. That is the reason why copper here exists as one atom of copper. Then it would be replaced by just one. And its molecular mass of an element. Ladies and gentlemen, it does not say molecular mass of a compound. It says molecular mass of an element. The element which is in this case iron. The element in this case which is now copper. That is the reason why they will have now 63.5. Let's try and do the other one with oxygen and quickly check. M of K is equals to 39.1 grams per mole. Then we have M of Mn, which is now 54.90 grams per mole. You just confirm and check with me from my periodic table. Mn, it's 55 according to this periodic table. So let me write it as 55. Grams per mole. And then we have oxygen. M of oxygen is just 16 grams per mole. Then what must we do? Calculate the total of KMnO4. That will now be 39.1 0.1 plus 55 plus 4 multiplied by 16. This will give you something like 158 grams per mole. Then what are we looking for? Percentage of oxygen. That will be how many oxygens do we have, or what is the molecular mass of one oxygen? It is 16 as an element divided by 158 multiplied by 100, and you get your final answer as something like 40.51% of oxygen. Motheo CDT?
I understand where I went wrong, sir.
Okay, thank you very much. Lesedi Katadi?
So I was able to get it, so I understand.
Thank you very much. Ratanang?
So I saw where I went wrong and understand.
Thank you very much. So the only key thing is on the equation, we work with the number of atoms from the molecular formula, and we work with now the molecular mass of an element. The only time we have a total is when we work with the molecular mass of a compound. The molecular mass of a compound. Ladies and gentlemen, if there are no questions, we are basically done with this one. Then it basically says we can move now to the empirical formula. Because remember, we are now working with more complex stoichiometric calculation. Determine the empirical formula or molecular formula, percentage yield of the reaction that now has been done. So we move to the empirical formula and we are building towards that. So let's now get into this, and this will be our empirical formula. Ladies and gentlemen, with empirical formula, we need now to have a definition of empirical formula. This is also from grade 10, but we are building to enhance the knowledge as well as increase the ability of getting everything right in the exam. Because the very same empirical formula, ladies and gentlemen, I saw a question paper of grade 12 last week. It was also asked in a grade 12 paper. So we need now to say, even though it is from grade 10, we must solidify and build moving forward. So this is now the empirical formula. Empirical formula. Also with the empirical formula, there are many ways of doing it. The one that works for you, 100%. But if you have the one that is somehow complex, try to avoid that, because there are so many ways of ensuring that you get this empirical formula. So the very first thing with empirical formula is the definition, or what is empirical formula. Empirical formula indicates the simplest ratio in which the elements of a compound are bonded to each other. Very, very important. So this is actually an arrangement or a simplest ratio in which now elements are bonded to each other. So we are going to use this in order for us to actually determine the equation as well as determine the molecular formula. Ladies and gentlemen, the very first step says you will be given mass, and that mass will be in percentage. Do not worry, because now if it is given as 35%, we can equate this to 35 grams. Why can we compare that? Because the assumption is everything happens in 100 grams of a sample. So when the examiner tells me, no, 35% of this, 40% of that, 15% of that, it basically says all that is basically represented in a form of a mass in grams as well as the percentage thereof. So if I'm told it's 35%, it actually means 35 grams. What must I do as step number 2? Divide the atomic mass to get the number of moles. Ladies and gentlemen, let's just say here, calculate the number of moles of each element. Here, let's say, calculate the number of moles of each element. And then from there, I will move straight to 4 and say, divide by the smallest number. After dividing by the smallest number, you will obtain a whole number. That whole number multiply each element. And after multiplying each element, it will give you now your empirical formula. But I am going to add 7 here. 7 is molecular formula. Molecular formula. So with the molecular formula, we'll need to have what we call a multiplier. What is this multiplier? Ladies and gentlemen, the multiplier is the number that we get that is going to tell us the actual molecular formula of this substance. Remember, the empirical formula indicates the simplest ratio. The molecular formula indicates the actual existence of the substances or of the molecular formula itself. So we are going to have the molecular formula, but how do we get now the multiplier of the molecular formula? The multiplier is equals to molecular mass divided by empirical mass. Empirical mass. Then it will give us the multiply. So it is basically the molecular mass, which is the total. And in most cases, examiners usually give this. Let me just say, always given in most cases. If it's not given, then somehow a hint will be given for you to be able and actually know what you need now to do. So this multiplier, we are going to use it to multiply multiply it with the empirical formula, this will give us now the molecular formula. The molecular formula. 100%, ladies and gentlemen. With that being said, it says, let me give you your 30 seconds to digest. Empirical formula, you've heard the name before. We are just emphasizing and ensuring that we understand everything. Luanle?
So it's a question. I just want to make sure that I'm using the correct thinking. So is the multiplier the big number in front of the element? Like if it was 2F and then there's a small like subscript 2, is it the big one?
It is the big one, yes. The one that you are going to use to get the small one or the subscript. Thank you very much. Now I have one example that we can try and do. And it basically says, determine the empirical formulae of the compounds of the following compositions per mass. So let's try to do this one. It gives you something like 6 minutes also. And kindly share your answers with me, and then we'll immediately discuss. Thank you very much for your answers. Let's quickly get into it. Like I said, ladies and gentlemen, there are so many ways of doing this thing. I was recently introduced to a table method, of which I found that it is somehow making things a little bit easy. So I saw a few of you using it also. I am very, very happy. Now the table will say you are going to have your mass and your iron there, and then basically the elements given. This is your table, and the mass here is 63.5 grams and 36.5. Then calculate the number of moles using m over molar mass. That is just now 63.5 divided by 56, and this gives you now 1.3 mole. You do the same for sulfur, is 36.5 divided now by 32, which is equals to 1.14 mole. Then you are done with your number of moles. Then they said divide by the smallest, divide by smallest, which will be 1.3 divided by 1.14, which is equals to 1.114 divided by 1.14. And this ones will give you now the ratio, which will be 1, 1. Then after that has been done, it's easy now to write down your empirical formula. So the empirical formula is just iron S, which is FES. And this is how you get your easy 6 marks, ladies and gentlemen. Inputs, comments, questions? Luandle?
Sir, I was just hoping, could Sir show us how to do the molecular formula if there's time?
That will be an activity for tomorrow because it is exactly 1927. So we will build towards having the molecular formula. Remember, the best thing first is let's have the empirical formula according to our steps. If we are happy with the empirical formula, then we add the element of molecular formula. So it's also coming, lady. It's just an issue that let's emphasize the point that everyone can actually first obtain the empirical formula in the correct way. So if the empirical formula is correct, then the molecular mass, the molecular formula should not be a challenge at all. Ladies and gentlemen, it is exactly 1928. I am not going to ask for reflections today. I'm just going to say thank you very much for all the hard work that you are putting in. Thank you very much for always trying to listen to this particular voice. And for me to you, ladies and gentlemen, let's meet tomorrow. There is no homework for today. Tomorrow we will do the molecular formula and also now move to the limiting agent or reactant. Then we'll be approaching the end of this particular topic. But for the purpose of enhancement, ladies and gentlemen, we are going to expose ourselves to high order questions of the exam, such that when we leave this topic, we know that now everything has been done in totality. Ladies and gentlemen, from me to you, thank you very much and have a lovely evening.
Bye, sir. You too.
Thank you, sir.
Good night, sir.
Thank you. Good night, sir.